Okay, so in this video, we're going to talk about our last blood identification test that I would like to talk about in the course. And before I do this, though, just a kind of a quick recap of everything else up to this point. We have now talked about the Kastle-Meyer test that used phenolphthalein. That's something that you can do, and you can make those reagents in the lab on the spot, and you'll be able to identify if something's a sample of blood or not. If you don't want to go through that trouble, then you can have two choices that are out there, and that's called the HemaStick and the HemaTrace. Both of those are fair game. HemaTrace is more specific than the HemaStick. The HemaTrace, again, uses these antibodies that we talked about in our blood typing in a way, and the HemaSticks basically uses a reagent-based reaction, very similar to the Kastle-Meyer test with the phenolphthalein. So we've gotten more and more specific. All right, so what I want to talk about now is another way that we can identify a blood sample. And not just identify a blood sample, but maybe see a blood sample that normally we could not have seen before. Okay, so what do I mean by that? Well, this next test is going to use UV light. That's all that it's really going to do, something UV nature. And the presence of a UV light is going to show some maybe body fluid stains that could be on an article of clothing, or it could be on a piece of carpet that has been cut out and brought into the laboratory for test. So a UV light is the only thing that's required here. No reagents, no nothing. Just a UV light will be able to do up to a certain part for us. All right, so what do I mean by that? Well, I got to kind of give you some basics here. So the basics is that we are talking about the UV region. All right, so for those of you that maybe are not in the instrumentation course yet, let's talk about the UV region. All right, so here we're going to have what we call the electromagnetic spectrum. So I'm going to write that out, electromagnetic spectrum. And the electromagnetic spectrum includes all energies. Now, when I say energies, I want you to think of colors, but these are colors that your eyeballs cannot necessarily see, all right? What we see is a very small sliver of that electromagnetic spectrum, and we call this the vis portion of the spectrum. Vis because it stands for visible, and this is where your red, orange, yellow, green, blue, indigo, violet come from. So Roy G. Biv. Every color that I see is coming from that very small sliver of the electromagnetic spectrum. And there's tons of other energies or other colors in a way out there that your eyeballs cannot see. So another region of this spectrum, if I look at Viz, I look at Roy G. Biv, and I see the V here, right? V. So what's next after violet is something called ultraviolet. All right, this is like superviolet, Popeye on spinach. And ultraviolet is abbreviated with a UV. All right, and that's the UV area that we are talking about, or that we're getting ready to talk about in the upcoming slides. If you look on the other side of this visible spectrum and you look at R for red, this R is, if you go below that, this is going to stand for infrared. And this is where we have infrared spectrometers, infrared energy that we're associating with. These are very low energy, which means they're not going to do too much damage for you, right? If you go out to a gym, maybe like Planet Fitness here in Wilmington, and you go into the back area, you're going to see a red light bed. That red light bed is an infrared bed, and there's so many studies that have been done on infrared, basically initiating cell growth, doing away with all of those wrinkles and the cottage cheese thighs that you might see on some people, or you might have some of those yourself. But it produces collagen for your cells and your skin to be very elastic. So it lowers your blood pressure. It boosts the antibodies into your system so you can fight off disease infection a little bit better. There's so many different studies on infrared energy right now, and all of it is good. Compared to ultraviolet light. And ultraviolet light is very high energy. and that has a tendency to burn. And this is typically how tanning beds work. So if you go to a tanning bed and you lay into that bed, you are getting bombarded with UV light energy. And within a matter of minutes, the outside surface of your skin is going to start to get crispy and smell like a piece of bacon. So that's something that you kind of want to stay away from, and you can't go and lay in a UV light bed and then turn around and lay in an infrared light bed on the same day and feel good about what you've just done. It doesn't work that way, all right? So this is the area of the electromagnetic spectrum that we are talking about. It flanks the visible, which means infrared's on one side, UV's on the other, and then the UV portion is the higher energy portion. The visible area typically goes from about 400 to 900 or 800 nanometers. That number is very wishy-washy because we're very uncertain of where this goes after 900 nanometers into the infrared. That's kind of where we start to go at that point. And I've wrote this kind of backwards, so just be careful. But 400 to 900 is typically where our visible is going to be. The UV region typically goes from 200 to 400. So this is our area, or what we would call a nanometer area that we are after. Nanometer is going to be abbreviated with an NM, okay? So this UV light energy typically goes from 200 to 400 most of the time. Now, again, that 400 is very wishy-washy. Sometimes people will say 400 chop, and at 401 we're not in the UV anymore. It doesn't quite work out that way a lot of times, but we are just giving you a range, and that range is a rounded off range that's very easy to remember. So that way you can kind of put this into your tool belt of useless information that you think that you might not ever use again. But sooner or later it's going to come around and you're going to know what it is. So because I've went through that discussion, what does that mean? Well, body fluids have a tendency to pick up in the UV region. So we know 200 to 400 now. And it can also be detected outside of that region with our naked eyeballs because we can see blood as well. That's a stain. So untreated blood has a very high absorption in the range of 300 to 900 nanometers. I mean, that's what you're seeing on the screen right now. And this kind of makes sense, all right? And the reason that I say that is because this 300 to 900, 400 to 900 was visible. And you can see dry blood with your own eyes. So this makes sense, right? But if we go a little bit below 400 and dabble into the UV region just slightly, we can also still pick up a blood sample. We can still detect it. It will show up very bright up underneath a UV lamp or a UV light. So it covers the visible range. It also covers a little bit of the infrared range. Not much, but we're kind of on the fringes a little bit. And it also covers a part of the UV range as well. The strongest absorption band for the body fluid. All right, so let me change my color so maybe you can see this a little bit better. The strongest absorption band is right here, 395 to 435, and that is for all body fluid. All right, so when I say body fluid, I'm also talking about things like blood and things like sperm. So if we are looking for anything, maybe a rape case or maybe an incest case, and we have to look at other body fluids besides the blood, then this is going to be a very good region for me to hone in on and shine that energy onto these stains or possible stains to see if, in fact, they are blood or body fluid. The maximum wavelength here is 415. And what we mean by that is that when we scan things on a UV vis spectrometer, we typically get this hump that shows up and it comes back down. And this tallest area of the peak right there, this is what we call the lambda max. It is my maximum wavelength And that's what that symbol stands for. So maximum wavelength. What that means is that that is the best number to analyze my sample at. Now, that's not the only number, okay? So if I'm making a sample in a lab, or if I have to analyze a sample in the lab, lambda max is going to be the most sensitive area for that compound. But look, it's got absorbance here, and it's got here, and it has absorbance there, and there, and there, and there, and there. And it also has absorbances here on this side. They're just not as much, but there's still absorbances that are assigned to that compound. Lambda max is the best one. It is the most sensitive. But I can go lower than that lambda max, and I can still go higher than that lambda max, and I can still get absorbance for those compounds. That absorbance never goes away. The only thing that we're saying is that lambda max is the best possibility that's out there out of all of the numbers, out of all of the specific colors. 415 is going to be the best. So again, you're going to see an external link here, and that external link is going to show you a little bit of people using a light kit in a real forensics laboratory. So just copy that link down, or just simply click on that link within the folder, and it will directly to the YouTube video directly, and you can watch it from there. So what does this thing look like? All right, so here is basically a piece of fabric, and I can visually see a stain with my eyes, right? So hold on. Let me just make this a little bit bigger maybe for you. So this is basically white light, okay? This is me not shining anything at all onto that piece of fabric. This is all that it is, and I physically see a stain here, right? I can see a stain that looks like it goes about here, and I can circle that with my eyeballs. No fancy light needed, all in the visible range. And if I look anywhere else on the piece of fabric, you know, it looks like there's something maybe right here. And then it also looks kind of blotchy right in here. I can't really tell, but there is a possibility that something might be there. Now, believe it or not, what you've seen that I've just done on the screen is something that a forensic chemist would do. They would actually take this piece of evidence and they could mark it. All right. Now, they might not mark it in the beginning, but they typically will take something like a Sharpie and they will outline the stains that are present on that piece of fabric or that piece of clothing that is submitted to the laboratory. This is not uncommon. So what you've seen me just do on the screen, that's kind of normal. But this is an old stain, all right? It's suspected to be body fluid. And again, this is just white light, and that is it. Now, what I've just done is that I have taken the white light and I have changed it a little bit. No longer is it white light anymore. So it looks like I don't really see anything new, right? I still see the stain, and that stain is still about right here. And look, I was correct. That stain does look like it continues on over onto this piece of fabric, and I can continue just to outline it, and there we go. I mean, this was not surprising. The difference is that I can kind of see it better, right? I can see the stain a little bit better. This area over in here in the beginning, that area was guesswork. I wasn't really sure. It looked like something, but I wasn't completely positive about it. And now when I turn on a UV light, that image shows up a little bit better. But that's not our only choice, right? I can also turn this light on, and this is 415. So, 415 specific. What was special about 415? Well, we talked about it. 415 was the lambda max. We said that out of the all choices of nanometers, wavelengths that I can dial into, 415 is the best because it's the highest, it's the most sensitive. And look at this. It shows up this stain tons better than that one or that one. So white light, typical UV light from a UV light box, and then here is specifically dialed in to 415. And look, if I go back to this and I flip to this, I actually see an area that maybe I did not pick up before, right? That is part of the stain. And I didn't really see that with the UV too much. I mean, I don't think anybody would have circled that there was something up in there. And then if you take a look at the white light, you definitely would not see it up in there, right? But all of a sudden, we now get an extra part of the stain that was not present or that I would not have identified in the very beginning. The rest of this stuff, the rest of it, we could see that with different versions of the light that we have shined onto the piece of fabric. And it also looks like something else does show up kind of over in here somewhere. But what I think is kind of funny, it could just be me, but look at this alien head right here. Just due to the piece of fabric, they're looking at you, right? Okay, so here's normal UV, and then here is basically the 415 lambda max. Again, I have went through and I have seen extra pieces of the stain, and actually I probably shouldn't have even cut it off. I probably should have just kind of zoomed on in and included that area too as part of the body fluid stain. All right, so there's 415. This is 450. So what we're doing now is that we're just changing it a little bit just to show you the differences between the two, okay? After you go outside of the lambda max, I go maybe higher and higher and higher, 415, and then I go to 450. It's just a different filter that gets applied to the piece of fabric. But, I see pretty much close to everything that I saw before. This area down in here maybe doesn't show up as much, but the main part of the stain is still present, and I can still see that. This is 495, and at 495, a second stain appears, right? Do you see that? Now I see a bunch of stuff like right in here as well. And that is something that I would not have picked up in the other light filters. Okay, so let me go back. This is 450 and this is 415. We said this was the best. All right, well, if I dial it up, that stain still has absorbance. We still see that stain. Just because I changed the number, it doesn't make it go away. It's still absorbing. Maybe not as bright, maybe not the best possible nanometer, but it's still going to work. Well, if I dial this up just a little bit more, past the lambda max, and I get to 495, a second stain appears onto this piece of fabric. And this second stain is actually the presence of semen, not just a possible blood sample. All right? All of the other stains that I had seen before in the previous slides, those were mainly blood hemoglobin based. Maybe I didn't see the blood. Maybe it was so faint in color. Maybe it was so old that some of the color had went away, but it's still showing up. But this is now presence of something like semen, another body fluid that has now been onto this piece of fabric that I can identify and circle and say that it's there. So 495 is going to be the key player here. That kind of gets cut off on your screen because I've zoomed in a little bit, but 495 nanometers. So normally what would happen is that you would take this piece of fabric inside and you would put it into a completely dark room of the laboratory facility, and you would take this light box and you would have a handle typically on the light, and you would shine the light on this piece of fabric and you would just circle where those stains are. So again, I would take the Sharpie and I would outline this area of the stain that I see, so that way when I go back to the original picture and I look at the staining under normal white light, I will have a dotted area that represents where maybe that other body fluid was present. So that way I can now take this piece of fabric to another part of the laboratory and say, please swab these areas, tell us for sure enough if this is blood or not, or tell us if this is semen. And then if it is semen or body fluid, then or blood, I can then use those areas and I can extract DNA from it, and I can run those DNA samples and maybe help identify a suspect or a killer or a raper, somebody, right? Okay, so as I flip through, there was kind of our last picture that we saw, 495, and then here 535. Now this is dialing it up even more, and what you're seeing here is a more pronounced color maybe. The problem though is that the stain slightly disappears in a way. Okay, I still see the stains, they're still there, but this one was kind of much better for me to see that second stain than at 535. But this is another filter that I can go through just to make sure that I find everything that I need to find onto that piece of fabric. So here's a comparison, and it's going to compare your original UV light with a UV light and a filter that shows you these other body fluids that might show up on a piece of fabric that doesn't really show up quite well under just a normal UV light only. Okay. These UV lights are going to be portable. They are not just strictly for a laboratory room, and you can take these UV lights and you can buy them on your own now. I mean, no big deal. Go onto Amazon, pay $30-40 for a little portable handheld UV flashlight or something, and you can take it to your next hotel room. You can take it to the next community bathroom that you use. Maybe go into the nastiest gas station that you can find in town, and then just turn the lights off and turn the flashlight on and just kind of look around and see what you see. Here, the problem though on the right hand side is that some of these flashlights, if they are not finely tuned and if they're not laboratory grade, or if you don't know what you're doing with them, it will pick up other stains rather than body fluid. Detergents and cleaning products are going to be the number one kind of cross contaminant here that will show up. So here on the wall, it looks like there's some sludge right in here, right? Like, what is that nasty stuff that's dripping down the walls? I don't want anywhere near that at all. And then over here down at the bottom where it meets this subway tile on the wall, it looks like it's just kind of festered up there on the ends of it. So is that body fluid? The answer is probably not. It could be, but probably not. And you got to keep in mind that other things fluoresce. So don't let that be a confusing part in the identification. We still circle those areas that are showing up as a positive readout. We will still swab those areas, but keep in mind that those areas might actually come back and there will be no body fluid. It will not be blood. It will not be semen. It will not be any other body fluid at all, period. And that is one cross-contamination or culprit that we see. Here's a lab desk, basically, or a cabinet area. It's metal. It's pretty sleek, non-porous surface. But here, when we turn the light on, you can see all of these drips and nasty things that are coming down off the surface of the lab counter door. This, again, is maybe not blood. It's probably not body fluid. At least I hope it's not. But this is just another presence of a contaminant. And again, those are typically cleaners and soaps and other things that are very common in those products. What you're seeing here in this picture, blood's not tricky, or blood is tricky. It doesn't naturally fluoresce, especially on dark colors. These dark colors are going to be very hard for you to pick out where these stains are going to be located. So the way that we treat and handle these black pieces of fabric is that we dial up the wavelength, and that wavelength is going to go from 3 to 400. That's kind of what you've been seeing in the other slides. And then all of a sudden, if I change this over to a 715 or 700, this is what happens to the black pieces of fabric. The black actually turns white, and these stains actually show up as a dark color when that begins to happen. So this will show up, these types of body fluid stains, on dark pieces of clothing or dark pieces of fabric a little bit better than your typical 300 to 400 nanometer ranges, maybe all the way up to 500 nanometer ranges in the very beginning in the early slides that I've shown you before. Here's another comparison chart. This is another 715 scan, and if you take a look at the left, that's the original piece of fabric. It looks Japanese. I mean, I see, you know, that type of writing on it, so who knows what it is, but it's completely black. And then over on the right hand side, you're seeing the stain that shows up. The fabric turns white again, and the stain shows up to be a darker area. Okay, so that's just another method that we can use in order to pick out a blood sample or pick out a body fluid sample. And it just really requires a simple light bulb. That's all that it is. So a light bulb gets plugged up into a big box. We flip the on button and we dial it in, or we use different filters in order to give me these nanometers that we can utilize to our advantage to see things that maybe are there that aren't showing up using my own eyeballs. So in the next video, we'll talk about our last method, and that last method is going to be called luminol.